The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Hello children, welcome back to the class. Today we will start our new chapter, Vision and the World of Colors. We have already studied about different phenomena of light, like reflection of light, refraction of light in the previous chapters. Today we will discuss about another phenomena of light known as dispersion of light. Have you ever noticed the sunlight through a glass scale, through a new scale? What can you see? You can see VIBGYOR colors, isn't it? Now, there is an experiment given in your textbook. See here, the sunlight is made to pass through a glass prism and look at the screen, or what will happen to the refracted light? You can see VIBGYOR colors, isn't it? VIBGYOR means violet, VIBGYOR colors, isn't it? Violet, indigo, blue, green, yellow, orange and red. You know sunlight, it is a white light. When this white light is made to pass through a glass prism, what happens? Refraction takes place. As a result, this white light splits into its constituent colors. Is it alone the sunlight that splits into its constituent colors? No. Instead of that, if you are using a torchlight, the same way it gets splits into its constituent colors. So we can tell white light, when it passes through a glass prism, what happens? After refraction, it gets splits into its constituent colors. This phenomena is known as dispersion of light. And here we can see white light, it constitutes of different colors. Such a light is known as composite light. Composite light. So what is composite light? Any light that is composed of more than one color is known as a composite light. And when this composite light passes through the glass prism, it gets splits into its constituent colors. This phenomena is known as dispersion of light. Clear? And the regular array of colors is known as spectrum. Spectrum. Okay, now listen. Any light that is composed of more than one color is a composite light. Dispersion is the phenomena of splitting up of a composite light into its constituent colors. The regular array of colors formed by dispersion is the visible spectrum. Clear? Look at this figure. Here, white light passes through the prism, and as a result, inside the glass prism, what is happening when the light enters the glass prism? Refraction takes place, and here also the refraction takes place. As a result, this white light splits into its constituent colors. From the figure, can you tell me which color deviates the most? You can see violet deviates the most and red deviates the least. What is the reason for this deviation? Why the violet color deviates the most and red color deviates the least? It is due to the change in the wavelength of these colors. All the VIBGYOR colors will not be having the same wavelength. Okay, and the deviation depends upon the wavelength of the colors. There is a table given in your textbook. Look at the table and see the wavelength of the colors. Yes. Violet 400 to 440 nanometer, indigo 440 to 460, blue 460 to 500, green 500 to 570, yellow 570 to 590, orange 590 to 620 and red 620 to 700. Okay, so from this table, which color has shorter wavelength? Violet has shorter wavelength. And what about the deviation of violet? Violet deviates the most. So, what is the relation between wavelength and deviation? As the wavelength decreases, deviation of light increases. Okay, as the wavelength decreases, deviation increases. That is the reason why we are able to see the array of colors. Okay, and from this table it is clear violet has the shortest wavelength and red has the largest wavelength. Is it clear? And when this white light enters the prism, here refraction takes place, and when it comes out of the prism also, deviation or refraction takes place, and the extent of deviation depends upon the wavelength of the colors.
Have you ever wondered why you see a rainbow in the sky just after a rain? Where do these vibrant colors come from? Well, this can be explained by the phenomenon of dispersion of light. Let's see how we can create this rainbow ourselves. You will require a white light torch, a cardboard with a pinhole, and a glass prism. In a closed room, place the cardboard between the torch and the prism on a table, draw the curtains, and switch off the lights to darken the room. Switch on the torch. A narrow beam of light passes through the hole and falls on the glass prism. Amazing, isn't it? Newton was the first one to realize that a white ray of light, such as sunlight, is composed of different colors. When white light enters the prism, it gets refracted, producing 7 different rays of colors. The angle of refraction is different for each color. Thus, each color bends through a different angle with respect to the incident ray, and the colors split up. Separation of a beam of light into its constituent colors is known as dispersion of light, and the band of colors is known as a spectrum.
Now, whether dispersion takes place only when light passes through a glass prism? No. So next topic is rainbow. It's a very natural phenomena, isn't it? And when will you see this rainbow? Usually in the morning and in the evening, isn't it? And sometimes we can see the rainbow after rain when the sun comes. മഴ കഴിഞ്ഞിട്ട് വെയിൽ വരുന്ന സമയത്ത് നമുക്ക് rainbow കാണാൻ പറ്റും. Okay. Now, the rainbow will be in the west in the morning. Okay, when the sun is in the east, we can see the rainbow in the west. And when the sun is in the west, we can see the rainbow in the east. Okay, അതായത് സണ്ണിൻ്റെ ഓപ്പോസിറ്റ് ഡയറക്ഷനിലായിരിക്കും നമുക്ക് റെയിൻബോ കാണാൻ പറ്റുക. So in the morning, we can see the rainbow in the west direction, and in the evening, it will be on the east. Okay, so actually what is happening here? Here there is no glass prism. So which one acts as a prism here? The water droplets in the atmosphere acts as a prism. So, how this dispersion is taking place here? Let us see. Look at this figure. When sunlight passes through the water droplets, when the sunlight enters the water droplets, refraction takes place. Okay, and when it comes out of the water droplet also, refraction takes place. What about inside the water drop? Their total internal reflection is taking place. You have already studied about total internal reflection. Inside the water drop, what is happening is total internal reflection is taking place. As a result, what happens? It gets reflected back inside the water drop, and when it comes out, we can see this white light splits into its constituent colors, VIBGYOR. So V and R. In between these, we can see other colors. Which color will be seen at the outer edge of a rainbow? Have you noticed it? It will be red. Okay, red will be in the outer edge of the rainbow, and in the inner edge we can see violet. When the position of the sun is near the horizon, the rainbow will be bigger. When the sun is much above the horizon, the rainbow disappears. Is it clear? Sunlight, when it passes through water droplets, undergoes refraction and internal reflection. The light ray emerging from the water droplets, which make the same angle with the angle of vision, have the same color. These droplets appears in the form of an arc of a particular color. Thus, there is red color at the upper edge and violet color at the lower edge. All other colors are seen in between depending on their wavelength. That is, we know different colors are having different wavelength, isn't it? In the same way, after refraction, what happens is these colors get refracted at different angles. Okay, that is red color refract angle ആയിരിക്കില്ല violet color. മനസ്സിലാവുന്നുണ്ടോ? ആ ആംഗിളിലെ ഡിഫറൻസ് ഉള്ളത് കൊണ്ടാണ് we are able to see the rainbow in the form of an arc. ഓക്കെ, ഇപ്പോൾ 42.7 ഡിഗ്രിയാണ് റെഡിന് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ അതായിരിക്കില്ല വയലറ്റിനുള്ളത്. അപ്പോൾ ആ ഒരേ ആംഗിളിലുള്ള കളേഴ്സ് ഒന്നിച്ച് നിൽക്കും. അപ്പോൾ അതാണ് നമുക്ക് റെഡ് ഒരു ആർക്കായി കാണുന്നത്, വയലറ്റ് ഒരു ആർക്കായിട്ട് കാണുന്നതൊക്കെ. മനസ്സിലാവുന്നുണ്ടോ? അതേപോലെ നമുക്കറിയാം ഒരു കളർ നമ്മൾ എങ്ങനെ കാണുന്നത്, ഒരു റെഡ് കളർ, ഒരു റെഡ് ഫ്ലവർ നമ്മൾ എങ്ങനെ റെഡായിട്ട് കാണാൻ പറ്റുന്നത്? ബിക്കോസ് ദ ലൈറ്റ് ഫോളിങ് ഓൺ ഇറ്റ് റിഫ്ലക്ട്സ് ഓൺലി റെഡ് ലൈറ്റ്. അതിൻ്റെ മേലെ വന്ന് വീഴുന്ന ലൈറ്റ് അതിൻ്റെ പെർട്ടിക്കുലർ കളറിനെ റിഫ്ലക്റ്റ് ചെയ്ത് നമ്മുടെ കണ്ണിൽ എത്തുമ്പോഴാണ് നമ്മൾ ആ കളറ് കാണുന്നത്. എ ഗ്രീൻ ലീഫ് അപ്പിയേഴ്സ് ഗ്രീൻ. വാട്ട് ഇസ് ദ റീസൺ? Because when light falls on it, only green color is reflected back. Rest of the colors are absorbed by it. Okay. When will you see an object as black? എപ്പോഴാണ് നമ്മൾ ബ്ലാക്ക് കളറായിട്ട് കാണുക? When it absorbs all the colors falling on it. ഓക്കെ, അതിൻ്റെ മേലെ വീഴുന്ന എല്ലാ ലൈറ്റിനെയും അത് അബ്സോർബ് ചെയ്യുമ്പോഴാണ് നമുക്കത് ബ്ലാക്ക് ആയി കാണുക. വാട്ട് അബൌട്ട് വൈറ്റ്? It reflects all the colors falling on it. Clear? So, in this case, what happens is these colors, these VIBGYOR colors are having different wavelength. As a result, what happens? It refracts at different angles. Due to the difference in the angle, we are able to see the rainbow in the form of an arc. What will be the shape of the rainbow when we are viewing it from an aeroplane? It will be in the form of a circle. പക്ഷെ നമ്മൾ ഇവിടുന്ന് നോക്കുന്ന സമയത്ത് ആർക്കായിട്ടാണ് കാണുന്നത്. Whereas when we view the rainbow from the aeroplane, we are able to see in the form of a circle. What is the reason for that? The reason is when viewed from an aeroplane, we are able to see 42.7 degree in all the directions. Okay, we are able to see 42.7 degree in all the directions. Because of that reason, we are able to see the rainbow in the form of a circle.
Splits up into different colors. Let's find out how a rainbow is created. A rainbow is formed in the sky with the help of two things: the sun and water droplets. These water droplets could be in the form of rain, cloud, or mist. Sunlight bends as it enters the droplets in the air. The droplets reflect off the sunlight internally and refract the light again as it moves out into the air. In this way, each water droplet acts as a prism and disperses sunlight. Together, millions of such tiny droplets form the bow-shaped spectrum in the sky. The acronym VIBGYOR is used to remember the sequence of the colors in a white beam of light. From the spectrum, you can see that red color bends the least and violet color bends the most.
Next topic is recombination of colors. See here, two prisms are arranged as shown. Okay, so here white light is made to fall on the glass prism. What happens when the light comes out of the first prism? We can see VIBGYOR colors, isn't it? And a second prism is kept adjacent to it, and what happens when these VIBGYOR colors passes through that prism? It gets combined and will give white light. Okay, so white light, when it passes through the first prism, gets refracted, or it gets splits into VIBGYOR colors, and when this VIBGYOR colors passes through the prism, it gets combined and you will see white light. Okay, this is known as the recombination of colors. Why we are able to see these colors, or when these VIBGYOR colors are combined, we are getting white light.
What will happen if we place another prism in front of the emerging spectrum? Did you see that you got back the original beam of white light? What if you mix these 7 colors together? Do you think you would get white light?
Now, you might have heard of Newton's disk, isn't it?
Take a paper disc and draw 7 sectors on it. Color each sector sequentially with the colors of the visible spectrum. Now, spin the disc. The disc will appear white in color. Remember that the disc just appears to be white. It does not really reflect back white light.
In Newton's disk, these VIBGYOR colors will be painted, and when this disk is rotated very fastly, will you be able to see these different colors? No, will not be able to see the different colors. Instead, the disk will be seen as white. What is the reason for that? This is because of persistence of vision. Okay, what is persistence of vision? When an object is viewed by a person, its image remains in the retina of the eye for a time interval of 1/16 seconds after seeing it. This phenomena is called persistence of vision. If more than one scene is viewed within these 1/16 seconds, the effect of all these scenes will be felt by the eye simultaneously. This, when we see an object, the image will be falling in our retina, isn't it? അപ്പോൾ നമ്മൾ കാണുന്ന ഒരു ഇമേജ് നമ്മുടെ റെറ്റീനയിൽ എത്ര സെക്കൻഡ് ഉണ്ടാവും? 1/16 seconds it will be there. അതിന് മുന്നേ തന്നെ അടുത്തടുത്ത കളേഴ്സ് വരുന്ന സമയത്ത് എന്ത് സംഭവിക്കും? അതിന്റെ ടോട്ടൽ ഇഫക്റ്റ് ആണ് നമുക്ക് കാണാൻ പറ്റുക. That is the reason why this disc is seen as white when it is rotated very fastly. This phenomena is known as persistence of vision. Can you give me some other example? When a torch is rotated very fastly, we can see it in the form of a circle. A rotating fan. When it is rotated fast, we will not be able to see the leaves, isn't it? Rotating wheel. All these are examples for persistence of vision. Next topic is scattering of light. Already we have studied light travels in straight line. If light travels in straight line, how you are able to see the light inside our room? Have you ever thought of that? So what is happening here? When sunlight reaches the atmosphere, it gets reflected by the tiny particles in the atmosphere. Okay, and gets reflected in different directions. And there are so many tiny particles in the atmosphere, isn't it? അപ്പോൾ ആ ലൈറ്റ് പല ഭാഗങ്ങളിൽ തട്ടി irregular reflection takes place. As a result, we are able to see the light all around. Is it clear? That is, when sunlight reaches the atmosphere, it undergoes irregular reflection, or it gets reflected by the tiny particles in the atmosphere and gets deviated to different direction. This phenomena of light is known as scattering of light. Okay, so what is scattering of light? Scattering is the change in the deviation brought about by the irregular and partial reflection of light when it passes through different tiny particles in the atmosphere. Once again, scattering is the deviation brought about by the irregular and partial reflection of light when it hits the tiny particles of the atmosphere. Okay, that is scattering. Because of that, what happens? This sunlight gets reflected to different direction and reaches all around. Okay, now do all the colors undergo scattering at the same rate? Let's see one experiment. Okay, there is an experiment given in your textbook. Just see to it. You can see water is taken in a beaker and a torchlight is made to fall on the water from one side of the beaker, isn't it? And the light emerging from the beaker is focused on a white screen. So what happens? And what you are doing? Sodium thiosulfate is added to the water at the rate of 2 gram per liter. അപ്പോൾ നമ്മളൊരു ബീക്കറിൽ വെള്ളം എടുത്തിരിക്കുകയാണ്. ആ വെള്ളത്തിലേക്ക് നമ്മൾ എന്ത് ആഡ് ചെയ്യാണ്? സോഡിയം തയോസൾഫേറ്റ് ആഡ് ചെയ്യണം. Okay, and add 1 or 2 drops of hydrochloric acid to the water. Now we are adding hydrochloric acid, that too 1 or 2 drops. ഒരുപാട് ആഡ് ചെയ്യാൻ പാടില്ല. So what happens? What happens? Chemical reaction takes place, isn't it? Sodium thiosulfate reacts with hydrochloric acid and sulfur particles are formed. Okay, അപ്പോൾ നമ്മൾ ഇവിടുന്ന് ടോർച്ച് ലൈറ്റ് അടിക്കുന്ന സമയത്ത് what happens? This light ray undergoes scattering by these sulfur particles. ഈ സൾഫർ പാർട്ടിക്കിൾസിൽ തട്ടിയിട്ട് ലൈറ്റ് സ്കാറ്റർ ചെയ്യും. എല്ലാ ലൈറ്റും എല്ലാ കളേഴ്സും ഒരേപോലെയാണോ സ്കാറ്റർ ചെയ്യുക? അല്ല. Okay, deviation will be different. നമുക്ക് കാണാം violet, indigo, blue. These lights will be having less wavelength. So it scatters away. Okay, പെട്ടെന്ന് സ്കാറ്റർ ചെയ്ത് പോകും. And on the screen, see here, and on the screen, which color is seen? You can see red. Okay, അപ്പോൾ violet, indigo, blue പോലുള്ള കളേഴ്സ് സ്കാറ്റർ ചെയ്ത് പോകും. Later you can see yellow, orange, and finally red color will be seen on the screen. Okay, from this experiment it is clear that scattering for red is less. Scattering is less. Why the scattering is less for red color? Because the wavelength of red is more. Okay, when wavelength increases, scattering decreases. That is the reason why on the screen finally we are able to see the red color. Because red color undergoes scattering very less and it can travel larger distances. That is the reason why red color is seen finally on the screen. So from this experiment it is clear that rate of scattering depends upon the wavelength. Or what is the relation between wavelength and the rate of scattering? As wavelength increases, scattering decreases. Okay, or we can say when wavelength decreases, scattering increases. Is it clear? So, which color undergoes scattering very less? Red undergoes scattering very less. Red color undergoes less scattering. Whereas violet undergoes more scattering because of its lower wavelength. Rate of scattering and the size of the particles are interrelated. As the size of the particle increases, the rate of scattering also increases. If the size of the particles is greater than the wavelength of light, then the scattering is same for all the colors. So in this experiment, when sodium thiosulfate reacts with hydrochloric acid, colloidal sulfur is precipitated. As the size of the sulfur particles increases, the nature of scattering changes. So, ആദ്യം ഞാൻ പറഞ്ഞു നമ്മൾ 1 or 2 drops എടുക്കുന്ന സമയത്ത് less small amount of sulfur is precipitated. As after some time, what happens? This colloidal sulfur or the sulfur particles, the size of the sulfur particles increases and the scattering changes. Is it clear? So next we will see the rate of scattering and wavelength. Colors like violet, indigo and blue have the smallest wavelength in sunlight. They undergo maximum scattering while interacting with atmosphere particles. Red has comparatively greater wavelength and it can overcome small obstacles and hence scattering is low. As a result, they travel greater distance. Okay, so red color travels more distance because of its largest wavelength. So which component color in white light undergoes maximum scattering? Violet undergoes maximum scattering. Next topic is color of the rising and setting sun. What is the color of the rising and setting sun? Orange red color we can see, isn't it? It is seen as red in color. Look at the figure here. From the figure it is clear that during morning and evening the sunlight have to travel longer distances. Isn't it? So when sunlight travels through the atmosphere through a long journey or during morning and evening, the sunlight have to travel long distances. So what happens? The sunlight gets reflected by the tiny particles in the atmosphere or it undergoes scattering. As a result, what happens? Colors like violet, indigo, blue. These blue color get scattered more. Okay, during the long journey, what happens is the blue color, which has the shortest wavelength, undergoes maximum scattering. And red color, which has the largest wavelength, undergoes minimum scattering and it travels longer distances and reaches our eyes. That is the reason why the color of the rising and setting sun is red. മനസ്സിലാവുന്നുണ്ടോ? അതായത് രാവിലെയും വൈകിട്ടുമാണ് സൺലൈറ്റിന് കൂടുതൽ ഡിസ്റ്റൻസ് ട്രാവൽ ചെയ്യേണ്ടത്. ഈ കൂടുതൽ ഡിസ്റ്റൻസ് ട്രാവൽ ചെയ്ത് വരുന്ന സമയത്ത് എന്ത് സംഭവിക്കും? അറ്റ്മോസ്ഫിയറിലെ ഡസ്റ്റ് പാർട്ടിക്കിൾസുമായിട്ട് ഈ സൺലൈറ്റ് സ്കാറ്റർ ചെയ്ത് പോകും. അപ്പോൾ സ്കാറ്ററിംഗ് ടേക്സ് പ്ലേസ് ആൻഡ് കളേഴ്സ് ലൈക്ക് വയലറ്റ്, ഇൻഡിഗോ, ബ്ലൂ. ബ്ലൂ കളറിനായിരിക്കും ഏറ്റവും കൂടുതൽ സ്കാറ്ററിംഗ് ഉണ്ടാവുക. അത് സ്കാറ്റർ ചെയ്ത് പോകും. Whereas red, which has the greater wavelength, undergoes minimum scattering and it travels larger distances or longer distances and reaches our eyes. That is the reason why the rising and setting sun is seen as red in color. And for the same reason, red color is given as the color of the tail lamps of vehicles. Okay, because red has the largest wavelength and scattering will be less, so it can travel larger distances and the person can see it more clearly. So what all things we have discussed today? We have discussed on dispersion of light, isn't it? And we have also discussed what is composite light. Any color that is composed of more than one color is a composite light. Any light that is composed of more than one color is a composite light. Okay, and we have also discussed on scattering and the relation between scattering and wavelength. So go through the class. If you have any doubts, you can clarify it with me. See you all in the next class with a new topic.